It's time for another book review. Today we are going to go over this book here, Computer Architecture by Caxton C. Foster. Now, the first edition of this book was back in 1971. The edition that I have here is from 1977, which is the second edition. So it is quite an historical book. But the nice thing about learning, say, computer architecture from an old book like this is that you don't have to bother with all of the details of modern CPUs. So in that respect, it does tend to get to the very heart of the idea of what a CPU is and how it works. And in fact, in this computer here, it builds up a little CPU, which it is called Blue. So let's go ahead today and we will review Computer Architecture by Caxton C. Foster. So let's first of all have a look at the contents of the book. So we see that we start off here in a typical sort of example. We have the representation of information. So we look at binary numbers, negative numbers, and we look at fixed point, floating point, and some number codes. So this is very typical for a basic computer science book. So we've got gates and elementary logic. So again, we're going to look at the basic gates like the AND, the OR, the NAND, the NOR, so on and so forth. And then we move on and look at the D-type, the JK flip-flop, the master-slave flip-flop, and different sequential logic elements. Now the third chapter here is on storage mechanisms. So this is really a bit historical because, as I said, this was produced in 1977. So there's nothing in that of much interest other than maybe pretty much historical. Now the next section, putting bits together. So it looks at basic structures for our computer, for example the control circuit here, and it looks at stacks and shift registers, pointers, linked lists, local pointers, and so on and so forth. And then it moves on to the elementary machine. So this is when it starts building up the machine that they call Blue. So we've got the programmer's description, the instruction set, the basic machine cycle with control unit, fetch, execute cycle, the arithmetic logic unit, and the circuits for the control unit. Variations in addressing. So this is when it starts looking into addressing modes, indexed addressing, indirect addressing, base registers, and there's a bit here which is on paging. And then we look at the input and output to our device, and then we cover some more instructions which are used in this machine, which they designed called Blue. And then there's a nice little section here on some older machines. So we've got this AMI 9209, we've got the 8080, and there's another Signetics computer 2650. So again, this sort of stuff here would be quite historical. And then it moves on and it looks at different types of ways of increasing speeds on your computer. So there's different architectures as well. So it goes through a few, again, historical designs. So, and there's a little bit here, I suppose, would be interesting on pipelining. And then it looks at parallelism and distributed logic. So the last two chapters here, and also a chapter here on tessellated computers. So the last two chapters here, although historical, they're still very interesting chapters to read. So that's the basic premise of the book. So let's go ahead and we will look at some of the chapters in a little bit more detail. So we have the information representation. So this is all just about different number systems. So there's some nice little diagrams here. We do have a little bit more detail as well in some of the mathematics. So again, all the types of basic number systems, and there's stuff on the fixed point and also floating point, and also doing some basic arithmetic. There's a nice little section here on binary coded decimal as well. So that's the first chapter. And the nice thing as well, there's some references at the background and at the end here. So of course these are going to be quite historical, but if you're interested in the history of this computer architecture, then some of these references would be quite interesting, I think. We then go on to the basic gates. So again, we build up the basic logic gates, and there's a nice little representation here of the basic gates that we can generate. And the nice thing about this as well is it actually shows you some implementations of the basic logic here. So here's an implementation of the NOR circuit. And it works through different basic building blocks. And again, nice little actual diagrams of the electronic circuit in order to implement, in this case here, a low impedance NOR gate. And then it moves on to flip-flops, and it covers some basics on the different types of flip-flops, JK flip-flops, master-slave flip-flops, and some of the packages that were available at that time in terms of integrated circuits. Now this third chapter is more historical, so it's kind of just storage mechanisms, but it would be interesting, I think, as I said, purely as in historical, if you're interested in the history of some of the computing technologies. But it's not something that I found in particular that I was had much use for. So we really kind of start with the computer design here, putting the bits together. And it's showing you here how we build up a little RAM. Okay. And some of the basic building blocks in order to read and write into a RAM. And then there's a bit here on push down stacks. And a shift register. And the nice thing is it builds this detail all the way through, and it actually is asking questions as well as it goes along. So here is a flip-flop for binary counting, so that will be binary counting in both directions, so it will be up and down. So these are nice little circuits that you can actually go ahead and just produce and test yourself on an online logic simulator. And again, it goes through some basic commands and a structure of a little program. And addressing modes as well. Okay, so now we're on to the basic elementary machine. So we really start building up the blue machine from this point on. So we've got a programmer's description of the machine. So a little schematic of how it looks, the basic instruction set for the machine. And then it shows you how the information is passed through the machine. and it's got the arithmetic logic unit here, the registers, and the extra registers here as well, and how to connect the registers to the bus, and the control unit as well, how we generate the control signals, and there's input-output instructions. So there's quite a lot of detail here. We have the arithmetic logic unit, and we've got the basic structures of adders and half adders and full adders, and a binary decoding tree for the blue, and you can see the all of the instructions here. And again, this control unit, and the control unit is actually split here, and I actually have taken a hardwired control unit and I have split it just the way you see here in order to generate a micro-coded control unit. So all of this type of structure looks very familiar to me, and in fact if you were to do my Design a CPU 2 course, you would see structures exactly like this. We then go on in earnest looking at addressing modes. So I talked about indexed addressing, indirect addressing, so all the basics of addressing and different types of addressing and why you would need it. And again, it's quite wordy, there's a lot of description, there's a bit in paging here as well. So again, some of it is be quite historical in nature, but still very interesting to have a read. And then we have the how to input and output into our device, stuff on handshaking, and again we have quite a few historical references here as well. And we have some extra instructions here for the computer. So here's a search instruction, there's a bit on push down stacks, a bit on the microprogramming, and here's a microprogrammed version of the computer blue. So it's actually, there's a lot of detail in it, and you can actually go ahead and build the computer here. And this section here actually covers a few microprogram computers or microcomputers that were available then and historically, so previous to 1977. So I don't know some of these, but the AMI 9209, there's a little bit on the 7-segment display. The 8080, so obviously I know that one. So it talks through a few of the older computers from the 1970s, and it talks through some of their architecture and some of their programming languages. So the last section here on very large computers, so very large computers for 1977, and what is actually interesting is the very last two chapters. So in the last two chapters here we cover parallelism and distributed logic, and a fascinating chapter at the very end here is on tessellated computers. So it goes through some of the details of the ideas that von Neumann generated when he was looking at self-replicating machines or self-replicating automata. So again, it is a little bit historical, but still a very interesting read. Now the nice thing about the book is that it does get into quite a lot of detail. It is based in 1977, so when you're reading it, you're actually reading something that is, as I said, and I have said many times through the video, is historical in nature. But we still go ahead and build up an actual functioning CPU, which they call Blue. And you could actually take the circuits here and build it for yourself. So if you're interested in a book that will show you how to build a basic CPU, but it will show you how to build it back in 1977. So in effect, you're taking a little leap back in time and you're visiting 1977 and you're building a computer from 1977. And you're also looking for some of the history behind computer architecture and computer design. Then a nice way to learn this is through this book, Computer Architecture, 2nd edition by Caxton C. Foster.